Hello guys. When I was learning about agentic AI, then I came across this web code and scorer library. It's pretty good actually. So I don't have the time to go into all of those details, but I will showcase to you what it can do. So I have this benchmark website that I'm gonna get in the moment, but I came across here a system prompt where you can see how you have. It's actually made by the Angular team, by the way. So what they did is they created this main instructions where tell the model like don't do weird stuff to not make it to not make it problematic for the build, and then it goes with style guide really. So you have things that you have to avoid, and then you have the best practices. You have the accessibility. I actually removed that from my system prompt because I want to check the actual working software and the quality metrics, and not focus on whether it works and it meets some quality from the UI perspective. I wanted to check it from the code perspective, right? And actually, it's a big problem in benchmarks. Most of the benchmark they will check things like does it work, does it pass the test, and they don't focus on the quality metrics at all. So I wanted to create a benchmark that actually solves that problem. And then you have all the bunch of stuff. So what I did, I took those into the evals. Evals are sort of like a unit test, but not really. They are using something called metrics. In web code and scorer, it's called rating. And then each rating will have an impact and a score reduction, and higher impact will penalize the solution more, and of course take the score reduction into the account. And then I wrote my own code graph tool. You can read more on my articles about it. But generally, the idea is that I could be using the linter, but the linter will not give me those labels, right? And it will also be pretty hard to, extend. Whoever wrote linter knows this. You have to understand a lot of things, and my code graph is just more flexible. So I use my code graph to label what I find in generated code. So an example, in change detection strategy, uh, you can have you can in Angular 20 you can omit the on push, and then I score it 100%. And if you actually put on push, which is the model's default, then I say 75%, and anything else is really zero. And then I have all those metrics from with slight modifications. I have them here, right? So you can actually check it on the website. So generally, you see like things like inject, function has to be used. It could be also, there's quite a lot of things actually. I check if the signals mutate. I check if actually signal is used and not observable. There is quite a lot of stuff. Actually, subscription management. Do you actually call subscribe, or you take until destroyed, or maybe async pipe? I check for those. Of course, no ng modules. I'm trying to find something that is pretty interesting for you in the templates. What I also do. Oh yeah, I check for things like template formatting. Like you should actually use pipes for template formatting. Ideally, the built-in pipes, maybe a custom pipe, which is a bit of an over engineering. And then, of course, like formatting in a component is not the best way. And then, yeah, a bunch of things actually. Of course, the template fault, the cognitive load. There's a lot, and it actually it gives you a pretty good quality metrics on top. Okay, the tasks. What did we do with the tasks? So I took basic tasks that come from Logula Academy. So whenever you finish like HTML or CSS course, or maybe you are already a developer and you want to learn Angular, so one of the first things you want to learn are those three tasks. So one is product details. So call an endpoint and get me with the simple architecture component model service. Show me the product, right? But show me some detail fetch from the backend. Then show me the list of those some, in this case it's users, but it could be anything. and then also create a login form. So create like a simple form, right? Where you can set up, like fill up the email and password and submit, and then see if you logged in. Yeah, that's it. So let's get to some interesting things here. So before we get to the scoring, which is the least important thing actually, what I wanted to convey today, but in the classical web code and scorer, the flow will look like this. I mean, there are a few flows, you can configure some of it, but this is like the basic. First, you need to install the init state, which is a fresh Angular 20 app. Then you have the generate, you call an LLM both with your system prompt and the tasks description, and then the LLM will generate the files that you need to save, and then you build and serve, right? That's it. And then of course there is a rating part, and it's actually a one shot, one pass, right? So it has to get it right from the first pass, which is not really agentic way, and I'm gonna get to that in a second. But this is like the bread and butter of benchmarking. Okay, so then we have those frontier models with some good open source model, which is the GLM and Minimax. And then note that it was before Qwen 3 came out. And then what happens is you will see if I tell the instruction in the instruction stage or in the system prompt, if I tell it how it's gonna get scored, it's gonna get pretty high values. And this is a bit surprising because when I was writing this feedback, I was expecting that the models will not score high because there is like, I don't know, 60 instructions, and I thought, you know, the knowledge cutoff and all the data, and Angular is a bit niche compared to React. I thought that it's not gonna score very high, but I was wrong. I mean, these are very high scores. These are the scores that a human would probably also miss or would take a lot of time to actually complete, especially guys. So each of these tasks takes about, so looking at the students from our academy, each of this is at least 1 hour. We give the 1 hour deadline for this, and then only like 20% of people complete it within the time frame. And then actually only like 6% scores with these scores. I mean, it's almost impossible that all the guys will score high on all those concepts. I mean, it takes also about a month to learn all this, right? For them. So it's pretty good actually. And then what you can also see the pattern that, you know, the Gemini and Opos decided not to use reasoning tokens because it scored on the build 100% and then decided it's fine, you know, I can get it done without reasoning because these are the simple tasks. And then you can see the GLM is high on reasoning. I mean, by default GLM is high on reasoning, and then the codex and the Minimax did the medium reasoning, but you can also see that the build is much lower. So this is actually an interesting thing. So what it means, so I ran it multiple times, and then if you build successfully from one shot, then you get 100%. And then of course you see, if I run it 100 times, only about 50% of the time it's gonna be building. This will be, of course I didn't run it 100 times, I ran it a couple of times, but generally this is the idea, you know. We calculate the build based on how many times it actually got it right and how many times it got it wrong. It couldn't build it after the generation. So this was bothering me actually. So of course it can fix itself. So it's a matter of adding one more prompt and providing that scope to it. But it triggered me. It got me thinking. Why is it like this? You know, why is it that we can get the high scores here but not high scores here? And I came with a new way of doing this. So this is the system prompt I showed you, instructing the model about those evals, and then I created a new system prompt, which is really the same except that I remove all the instructions for the quality checks. I just kept the ones that are like, don't break the build, right? I mean, you're in Angular, make sure you follow a basic stuff. So this is the basic stuff, and then I run exactly the same benchmark on exactly the same evals and exactly the same tasks. So what's the result? So the result is that the model didn't score high on evals, of course, because I didn't tell you how I evaluate it. So this is an equivalent of an engineer writing short prompts and not having any rules set up. It got mistakes in code, but it scored 100%. This tells me that the way those models are fine-tuned in a post-training using reinforcement learning, they take build and testing. I don't have a testing in this column, but I'm pretty sure about it. Testing scores high, which is how all the benchmarks are working, and which is why I created this benchmark, because I wanted to test something different. So I sort of started to prove the point that the same pipeline but different system prompt yields different results. But then I was thinking, okay, but maybe that's not so bad. Maybe what we can do is to take this as a base. Hey, we are passing, sort of like what developers in TDD cycle would do, right? A developer first would pass tests. Of course, first is to write the tests and be read, and then go to the green stage, and then there is a blue stage, which is like refactor it. So I was thinking maybe it's actually a natural way. What if I could add the refactor stage afterwards? So what if I could provide the feedback of the evals afterwards, one by one? Because if I provide all of it again, too many instructions, things will you will have the context bloating, and it will start skipping some of the steps. So maybe if I can provide a feedback one by one, or maybe spawn multiple agents at the same time and then solve it, that could be a solution. And it turns out it's actually working. So all those models with the proper addition of one step after the generate and after the saving and building and serving, I can now add one more step saying score, and then add the actual quality checks, and then get back to the generate, right? So with this intact, the models were scoring 100% and still keeping the 100% build. Of course, it's using more tokens, it's a little bit more expensive, but the quality and the correctness is there. And then I went one more step ahead. I was thinking, this doesn't seem like a challenge for the models, for the frontier models. What if I could test it on cheaper models, maybe free models, or models I can, like open source models that can run on my local machine? So you can see also these, of course, don't look at these metrics, because the repo by default is like having errors, so it doesn't build, because we focus on solving one task at a time, right? So generally, you see the list of models that got it 100% based on the feedback is pretty long. Only somewhere here there is some slight things losing. And the workflow is like this: we generate, we save files, and then before we build, we also lint. And then if the lint is not there, we repair, and then this runs in circle, and then we build. You could argue that actually we could do it after the build. I didn't test that, but I can tell you it would work as well. But the only problem is that after the build, you would have to come back and make sure provide both feedbacks, build and the lint, right? So this way I wanted to, to solve it, and it's working. So it's actually 100% on models like Quen Coder that you can run on your local machine. So this benchmark ran later. It took me time to get to this stage. So the Quen came out and I wanted to test it. And it's pretty good actually. And also like the older models are open source, and some pretty old models actually, like a DeepSeek. You can still get it to work, and most of those are like free or very very cheap to run. So yeah, that's it. What I wanted to leave you with is that actually I believe this is an engineer's job now to design those agentic flows and those workflows, and adding stages, providing context, giving it tools, and giving it rules. And with the proper setup, you can actually yield amazing results. And then the next step is to actually make it more and more autonomous, where you only check the final score, but then you actually have to have this scoring in place. So if I were a developer who learns this AI stuff, of course I want to learn AI, which is very important, but I would really focus on quality checks, on those guardrails as they call it, or gates, right? Which I would make sure that I would provide enough context in the right time for the model, and then the model will solve it. So yeah, follow me up for more stuff.